Hello there, everyone. Today we tackle one of the most puzzling, deepest concepts in all of science, quantum entanglement. Buckle up, for what we'll see today indeed calls into question the very foundations of our reality in order to gauge just how perplexing this idea is. You should know that even the geniuses who invented quantum mechanics were completely baffled. Take Richard Feynman, for example. He summed up the paradox to perfection. On one hand, it is a truly powerful tool we use daily in our technologies, but on the other, its deep nature still eludes us completely. And that's not all. There's more. One of the theory's founding fathers goes even further for him. If we don't find it strange, it's because we haven't understood this sense of strangeness. It's not a bug, it's proof we're finally grasping what it's about. And of course, there's Albert Einstein, his famous dispute. It wasn't about math, it was about the universe's philosophy. He could not, but not at all, accept a reality based on chance, a reality that quantum mechanics nevertheless seem to impose upon us. So, what is the source of this mystery that has troubled the greatest minds of the 20th century? Well, the answer. It lies in a phenomenon so counterintuitive that it has its own little name, quantum entanglement, to really grasp how revolutionary the int is. We must first understand the most fundamental rule of the universe, its speed limit. Nothing. Absolutely nothing. No information can travel faster than light. It is a cosmic limit, an insurmountable barrier. It is the very foundation of Einstein's theory of relativity. To make it more concrete and tangible, let's imagine a small journey to the nearest star. A simple little tweet would take 4 long years to reach Earth. A real-time conversation would be impossible. Each and every exchange would take 8 years in total. And that's where it all truly changes. This is precisely where quantum mechanics arrives and seems to pulverize this iron rule. She offers us a link that defies space and time. So quantum entanglement, what exactly is it? It's that two particles are linked in a very special way. If we measure one property of a particle, such as its spin, it instantly affects the rotation of the other, even if they are separated by billions of kilometers. Surely such an idea. It wasn't accepted that way by snapping fingers. It provoked one of the greatest clashes in the history of physics. On one side stood Einstein, who outright rejected this spooky action at a distance. For him, it was incompatible with relativity. And on the other side stood Bohr, arguing that the quantum world followed its own rules indeed. That's all. Rules quite different from ours, altogether. And for decades, this debate remained entirely theoretical. It was somewhat a salon debate indeed. If you like, there was no way to run an experiment to know who was right. It was philosophy, not yet experimental science, but all that was going to change. The debate had finally left the blackboards to enter the laboratories. The question could finally be tested in the real world. After the death of the two towering giants, a physicist named John Bell found the key and devised a theoretical test, a method to force the universe to tell us whether it obeyed Einstein's rules or Bell's. His theory was ready at last. All we needed was someone bold enough to put it into practice, and that someone was John Clow. What is fascinating about this story is that he wasn't even an expert in the field. He was an astronomy student who admitted he struggled with quantum mechanics, but he saw the potential in Bell's idea and decided to try it. There, Clauser's results were truly staggering. And a little later, the even more precise experiment by the French physicist Alain Aspect swept away the last doubts. The universe is indeed truly strange as we thought, and on this precise point, Einstein was wrong. Today, we no longer question whether quantum entanglement does still exist. It's a fact, a pillar of physics. It has become a tool we are barely mastering to build tomorrow's tech. We're talking about quantum computers that could solve problems far beyond our supercomputers. We speak of inviolable communication or even information teleportation. The phantom action of Einstein is at the heart of the coming great technological revolution. And that leaves us with the most dizzying question of all. We have proven that Bohr was right, that entanglement is indeed truly real, but we still have no idea how it works. How can two particles communicate faster than light by breaking the cosmos' most basic rule? And the mystery itself remains unsolved.